Section 2-6 is on special functions. The first special function we're going to take a look at is called a piecewise function. And it's a function that has two or more distinct parts. And it's written like this, where f of x is equal to 2 or 3 or maybe even 4 different things. And what f of x equals depends on what the range is, what the x values are. So another way of thinking of this is, remember, f of x is another way to say y. Y is equal to x plus 2 when x is less than 0, and y is equal to x, that's the second part, when x is greater than or equal to 0. So in other words, they're kind of like two parts of a line. One part of the line is y equals x plus 2, but that's only when x is negative. And the other line is x equals y equals x, but that's only when x is greater than or equal to 0, when it's positive. I think part of the trick to doing this is to graph each line separately and do it lightly in pencil, and then just erase the part that doesn't apply. So it's going to be a little difficult to do with this pen, but I'll see what I can do here. So let's start with a line. Suppose I were just graphing y equals x plus 2. I would start with a y-intercept of 2, and I would go up 1 and right 1. So my line would look something like this. Okay? But the only part of this line that I need is the part where x is less than 0. Here's my x-axis, and right here, x is 0. So I only need the part of the line that's to the left, going in the negative direction on the x-axis. In fact, x can't even equal 0, so I'm going to erase these dots, and I'm going to put an open circle right here where x is 0, and my line going this way is going to be everything where x is less than 0. And that's the first piece of my piecewise function. The second piece is the line y equals x. My y-intercept is 0, and my slope is up 1, right 1, or down 1, left 1. Okay, and that's the line y equals x. But the only part of this line I need is when x is greater than or equal to 0. So what that means is I don't need these parts over here that are negative. I just need this part of the line right here. And that's what a piecewise function looks like. Probably the best way to do this is to graph each piece and then erase the part that doesn't apply. The second part of this is to identify what the domain and range are. And to do this, you really just have to look at the graph. So for the domain, what can x be? X can be all real numbers. X can be any number. And then what can the range be? What's the range? What can y be? In this case, y can be anything. So my range is also all real numbers. Okay, let's take a look at another one here. This piecewise function has 3 parts to it. Graph f of x, which equals negative 3x if x is less than or equal to negative 4. F of x equals x if x is greater than 0 but less than or equal to 3. And f of x is equal to 8 if x is greater than 3. So let's think of this as 3 parts. I need the line y equals negative 3x when x is less than or equal to negative 4. I need the line y equals x when x is between 0 and 3 and can include 3. And then I need the line y equals 8 when x is greater than 3. So let's start with the first part of this. The line y equals negative 3x. That has a y-intercept of 0, and a slope of negative 3 goes down 3 and right 1, down 3 and right 1, or up 3 and left 1, up 3 and left 1. And I need this when x is less than or equal to negative 4. Oops, unfortunately, I don't think I have enough spaces here. I'm going to have to just kind of pretend that it goes up to here. Because right here is where x is -4. So I need just this part of the line. That's not very straight. Let's try that again. I need just this part of the line right here. I only need the line y equals -3x when x is less than or equal to -4. So actually all of these dots here, I don't need any of those, so I'll get rid of those. Now I need the line y equals x when x is between 0 and 3. So the line y equals x, remember again, looks like this. But I only need the part that does not include 0. So that means right here at the origin where x is 0, I need an open circle, and it needs to go up to x equals 3. So 1, 2, 3. So this is the only part of the line I'm going to keep, and I don't need that dot right there. This part of the line here is the line y equals x when x is between 0 and 3, not including 0, but including 3. Now I need the line y equals 8, and remember that is just a horizontal line through 8 on the y-axis, but I only need the part of that where x is greater than 3. So actually I've got to get rid of that. Right here x is 3, but I don't need 3, it's got to be greater than 3, so it's going to look like that. Okay, that's my piecewise function. It's got all three parts to it. Now I need to identify the domain and range. This is going to be a little more complicated. The domain is the set of all x's. Well, let's see, so what can x be? X can be less than or equal to -4, or x is greater than 0. Because notice, from here to the left, where x is less than -4, I do have part of my function, but I don't have any pinkness, really, between -4 and 0, and it doesn't include 0, but anything a little bit bigger than 0, it keeps going all the way, because I've got this piece here, and then my y equals 8 picks up there. My range, well, where is the pink line? There seems to be pink line, let's see, up here, where y is greater than 12. Let's see, the set of all y, such that y is greater than or equal to 12, because this point right here is the point -4, 12. And what other pieces do I have? Y also equals 8. And one more piece here, y is between 0 and 3. Not including 0, but it does include 3. Okay, now there is a way to graph piecewise functions on your calculator. It's pretty complicated, and I think it's probably just easier to do it on paper. Sketch the lines that you need and erase the parts that you don't. If you'd like to see a more detailed explanation, they actually may have me walk you through this on your calculator. Come see me during my office hours. Special type of a piecewise function is called a step function. One type of a step function is called the greatest integer function, and it's written like this. F of x equals, and we've got kind of double square brackets around it. And it means the greatest integer less than or equal to x, or basically round down to an integer. I wanted to show you the graph in the textbook, but the one in the iBook is incorrect. But I did find another one to show you an example of. You can also graph this in your calculator. Since we're not really going to focus on step functions a whole lot, I wouldn't worry too much about this. But just to give you an idea of what one looks like, here's one from an example in the textbook. Notice that x is not one particular value, but it's a whole range of values that are associated with one y value. So in this case, when x is between 0 and 1, not including 0, but including 1, so notice doesn't include 0, but it does include 1, your y value is constant at 50. And then it steps up for when x is between 1 and 2, not including 1, but including 2, it steps up to $85 and continues to step up. So in other words, for a whole range of x values, you have one given y value. It's a little complicated. We're not going to worry about graphing these, but I just wanted you to see what it looks like in case you run into these again. Now here's a more important function, and we actually dealt with these in Algebra 1, and these are absolute value functions. An absolute value function is also a piecewise function, and when you graph it, it looks like a V. Easy way to remember that is it's an absolute value function, and it looks like a V. So I'll show you how to do this on the calculator, but let's do one of these by hand first. First, graph the function f of x equals the absolute value of x minus 3. So the first thing I want to do is find the vertex. I want to find that pointy part at the bottom of the V. So to do that, I'm going to set the stuff. So let's say to find the vertex, set the stuff between the bars equal to 0. Okay, so if I take the stuff between the bars, x minus 3 equals 0, that means x equals 3. This is going to be the center value in my table. So I'm going to put this in the middle of the table. So let's make a table of values here. And in the middle I will have the absolute value of x minus 3. Remember what that means is I take x, subtract 3 from it, and then take the absolute value of that. And that will give me my y, or f of x. Okay? Now, x equals 3 is going to be that pointy part at the bottom of my graph, so I want to have 3 in the middle of my table here. And then I'll pick two numbers smaller and two numbers larger. And this isn't too difficult. Let's just go ahead and plug them in. So the absolute value of 1 minus 3. 1 minus 3 is negative 2. The absolute value of negative 2 is 2. Absolute value of 2 minus 3. Absolute value of negative 1 is 1. Absolute value of 3 minus 3 is 0. Absolute value of 4 minus 3 is 1. And the absolute value of 5 minus 3 is 2. Okay, let's go ahead and graph this on our table. Or graph this on our chart here. So I had the value 1, 2, the value 2, 1, 3, 0, and there's my V. Okay, and let's go ahead and identify our domain and range. So what can x be? X can be all real numbers. So I can choose any value I want for x and plug it in, and that will work. Okay. Now what can my range be? What can y be? Notice that this graph hits the x-axis, but it never goes below it. So this means that my y values have to be greater than or equal to 0. Now, there is a way to do this in the calculator, and I think maybe we'll go ahead and try that. If you go to the Math menu, so we'll use our regular y equals, but from the Math menu, the number submenu, I can get the absolute value. So let's give that a try. Okay, so I'll go to y equals, and I'll go to Math, arrow over to number, and there's absolute value. So I'll put that in there, and then I'll do x minus 3. And I don't need to worry about closing parentheses, and I can just hit graph. That gives me my graph, and remember, if you would like to see your table of values, you can do second graph, and it will show you your table of values. Okay.